Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about angle bisectors of triangles, and this is section 5.3 in your book, so for you geometry students, section 5.3. So let's first look at a definition of what an angle bisector is. An angle bisector is a ray that cuts an angle in half. So here we need to look at this angle ABF. And if I were to draw an angle bisector here of this angle, I would draw a ray that literally cuts it right in half. So hopefully my eyes are not deceiving me. That looks like it's about in half. And let's call this point M here. Now, what we can say, or the way we know that a ray is a bisector of an angle is by the two arc marks inside the angle. So here we could draw a little arc, and then here we could draw a little arc. And those two arcs indicate that angle ABM and angle MBF are congruent. Okay? What we can also say is that once we know that a ray is an angle bisector, we can also say that any point along that ray is going to be in the middle of the angle. So here, I've got this point here, and I can drag this point anywhere along this ray, and it's going to be in the middle of the angle. And really, what else I can say here is this, that this point, we'll call it, go ahead and call this point H. Okay? We can say that point H is equidistant from the two sides of the angle. So here, if I was to say point H, from point H to the side of the angle, BF, we could say that from here to here is the same distance as from here to here. Now, it's not just any distance. In fact, the shortest distance from the point H to the side of the angle, BF, is not just any line I draw. So I can see here, I got a line here. Let's say I draw this line from H to the ray BF. Well, that line is actually going to be longer than if I drew this line. And those two are actually going to be even longer still than if I drew this line. Now, the shortest distance from the point H to the side of the angle BF is a perpendicular line going through the point H. So here, if I take this point here, it has to be a perpendicular here. We have to have that box to indicate it. So the point H, the shortest distance from point H, let's go ahead and delete that one. Uh-oh. Lost my point there. So let's just go ahead and call this point W now. Okay, so the shortest distance from point W on the angle bisector to the side of the angle BF is a perpendicular line going through the point W to the side BF. If it's not perpendicular, like say this, then we can't say that it's going to be equidistant to anything. Okay? So, and let's go ahead and call this down here, we'll call this point K. Get rid of that point. Uh-oh. Get rid of that point. So let's go ahead and just call this point L, and we're going to call this point over here R. So if I were to draw the shortest distance from point W to the side of the angle BA, then that would look like a perpendicular line from here to here. So let's go ahead and draw that perpendicular mark. Okay. Now, what I'm saying is that if the ray BM is an angle bisector, then I can say a point W on that ray is equidistant from the two sides of the angle. So I can say this is congruent to this. Okay? And again, this applies for any point on the angle bisector. So if I were to move this point up here like this, that's still equidistant. And if I move this to, but again, the distance has to be a perpendicular. It can't just be any distance. So if I move this here, then I need to move this to a perpendicular here, and I need to move this one to a perpendicular here. So that we have this kind of thing going on. Now let's go ahead and throw that away. We'll throw this away. Okay, so if I move that point W, then this needs to be a perpendicular, and this needs to be perpendicular, and therefore I can say that this is congruent to this. Okay? Now let's say we have, let's say I delete this. Let's throw W over here. Let's delete this. Delete that. Delete that. And delete that. Let's say I have an angle again. So we have an angle ABF. And let's say we don't know that these arc marks are here to indicate this is a congruent angle. But let's say we did know this. Let's say we knew that from here to here and from here to here was the same distance, and it was perpendicular to the side of the angle. So here's the perpendicular marks. Here's our congruent marks. Okay. Now, if we see a figure like this where the point here on this ray is equidistant and a perpendicular to the side of the angle, then we can say that ray BM, so this ray right here, is a angle bisector. So we can draw in little arc marks here to indicate that this is going to be congruent to this. Okay? Now, let's toy with this a little bit. If I were to draw in here, let's say I just gave you this, that this segment was congruent to this segment. Okay? Then we could not say anything at all about the ray BM being a congruent segment. So let me share why here. So I can change the ray here. I can change this ray, and I can do this. I can start to manipulate the sides of this ray so that this is going to maybe look like it's equidistant, but it's really not. So here, if I take a look at this segment here and this segment here, it looks like those would be congruent. And even if they are congruent, I can draw this in here. Even if those are congruent, that doesn't necessarily mean that BM is an angle bisector. It has to not only be congruent here, but it also has to be perpendicular. So as soon as I change this diagram and I say, okay, this and this, and let's move this maybe towards the middle more. Once I change the diagram and I have perpendiculars here and here, and these are congruent here, then I can say, hey, the ray BM, so BM is an angle bisector, therefore I can draw little arc marks. Okay, so be careful about the notation here. Now let's take a look at what this would be as far as in a triangle itself. So let's go ahead and delete that. Let's delete that. Delete that. And that one. let's throw all the rest of this stuff off to the side here. And then we'll delete this point and this point. And let me complete the triangle ABF. Okay, so now we have triangle ABF. If I were to draw an angle bisector of the triangle, it would look like this. It would start at one of the vertices here, and it would cut the angle in half, like so. And I could do the same for this one as well. I could cut the angle in half here, and then cut the angle in half. Okay? Now, what you should notice now is that all three of the angle bisectors of this triangle meet at a central point. So this central point here in the middle, let's go ahead and label that this point here. Let's put a little dot, and we'll call that point R. So we can say that the intersection of all the angle bisectors of this triangle intersect at the same point. What is significant about this is that the point R is equidistant from the three sides of the triangle. So for example, the distance from R to this side, the distance from R to this side, and the distance from R to this side is congruent. Now it may not be exactly look like it in this diagram, and that's okay because this is just a rough sketch. However, remember the shortest distance from any point here, R, to a side, so for example if I was going from R to this side, is a perpendicular. So what's congruent is going to be the perpendicular line from here to here, from here to here, and then from here to here. And they all have to be perpendicular for them to be congruent. Okay. This concludes our lesson on angle bisectors of triangles.